Hey everyone, and welcome to The Explainer. So if you are a first-year computer science and engineering student, you are in exactly the right place. Today, we're diving really deep into a topic that is going to absolutely fundamentally transform your career trajectory. We are breaking down the architecture of modern adaptive software engineering. And look, this isn't just another subject on your syllabus. This is literally the master blueprint for your entire professional life. So let's dive right into this and take a real look at the reality of the industry you're about to enter. Let me just start off by asking you a question, and I want you to be brutally honest with yourself here. When you decided to study computer science, you probably thought your main job was going to be sitting in a dark room, typing out lines of Python or Java, right? Is knowing how to code really enough to succeed out there today? The answer is a massive, resounding no. Writing code? That's just the starting line on your journey. It is the absolute bare minimum. I mean, if all you know how to do is write code, you are what the industry used to call a code monkey. But the industry doesn't just want coders anymore. It wants system architects, it wants adaptive engineers, people who actually understand how that code lives, breathes, and survives in the real world. Okay, so here's our roadmap for today. 1. Beyond just writing code. 2. Traditional versus modern engineering. 3. The complete modern workflow. 4. Skills for lifelong learning. And 5. Your future career roadmap. All right, let's jump right into part 1, beyond just writing code, or the industry transformation. So software development has completely evolved, right, into the AI era. It's not just about building a standalone app anymore. We're talking machine learning deployment, actually giving your app a brain so it can learn and adapt on its own. It's about cloud computing integration, so running your software globally on platforms like AWS or Google Cloud, so anyone can access it instantly. It's about deep automation and continuous delivery, where literally a few keystrokes push your code from your laptop to millions of users in minutes. It's also about embedded security, because you really need to make sure your app isn't tomorrow's big data breach. And crucially, none of this happens in isolation. It requires really high-level cross-team collaboration. Companies absolutely expect you to master these interconnected concepts from day one. You can't just hand off your code and say, all right, my job is done. Moving on to section 2, traditional versus modern engineering. Basically, how the tech giants operate. The shift here is honestly night and day. On one hand, you have traditional software development. This is the old world. It was siloed, it was agonizingly slow, and it relied on completely isolated coding. Developers wrote code, essentially threw it over a metaphorical wall to the operations team, and basically just crossed their fingers hoping nothing caught fire. That method is practically extinct now. On the other hand, we have modern, adaptive software engineering. This is an integrated powerhouse. It combines agile planning, DevOps, security, cloud architecture, and MLOps. Everything is connected, and everything moves incredibly fast. And hey, if you're sitting there thinking this is just some academic theory, think again. Listen to these names: Amazon, Google, Netflix, Microsoft, Uber, Spotify. This is exactly how they build, secure, and deploy software at that massive scale. In fact, Amazon deploys new code to production every few seconds. You definitely can't do that by hand. When you hit play on Netflix or request an Uber, you are interacting with these exact adaptive, automated, cloud-native systems. So by learning these modern methods, you are literally learning the playbook of the most successful companies on Earth. Okay, section 3, the complete modern workflow. Let's connect those course outcomes. The really crucial point to grasp here is that absolutely none of these topics exist in a vacuum. It all kicks off with agile planning and software engineering, so organizing your team's chaos into very clear, actionable goals. That flow feeds directly into step 2, DevOps and cloud deployment, which is automating how your code is built and hosted. But obviously, you can't just deploy blindly, which brings us to step 3, DevSecOps and continuous monitoring. This essentially weaves security testing right into the very fabric of your deployment. And finally, it culminates in step 4, MLOps, injecting machine learning models securely and efficiently into your live running applications. It's just one beautiful, continuous loop. Now, to actually pull off that continuous loop, you need specific tools. And we're not just memorizing vocabulary words here. For example, in DevOps, you're going to containerize apps with Docker, meaning you pack up your code and its entire environment into one tidy little box so it runs flawlessly on any computer. It completely solves that classic, well, it works on my machine excuse. In security, you'll use tools like Trivy to act as an automated security guard, hunting down vulnerabilities before your code even goes live. And for MLOps, you'll leverage platforms like AWS SageMaker to deploy real AI models. So try to see this not as some boring syllabus, but as the practical toolkit of a highly paid, highly sought-after engineer. Which brings us to Section 4, Skills for Lifelong Learning, How to Adapt to the Future. So this modern workflow, it builds way more than just your technical capability. You aren't just getting technical skills like cloud, AI, and DevOps. You are building professional skills, specifically an engineering mindset that can look at a massive, complex real-world problem and know exactly how to break it down. And honestly, equally important, you're developing soft skills, primarily team collaboration, because no massive global software system is built by just one person hiding in a basement somewhere. It requires really high-level communication and coordination to make sure all these moving parts actually work together. Look, technologies are going to evolve every single year of your career. Seriously, the JavaScript framework that everybody is obsessed with today might be totally obsolete in 5 years. And that is exactly why this course emphasizes continuous learning and adaptability. By focusing on the fundamental concepts, things like cloud-first development, AI-powered problem-solving, and deep automation, you are totally future-proofing yourself. You are learning how to adapt to future technologies, rather than just memorizing today's fleeting trends. All right, let's look at Section 5, your future career roadmap, the ultimate journey. Let's trace out a timeline here, because this is your actual journey. Right now, in Semester 1, you're doing foundational learning. But apply these adaptive principles, and honestly, by year 3, your college projects are going to easily land you premium internships. By year 4, you're not just an entry-level coder. You're stepping right in as a highly competent software or DevOps engineer. Fast forward to year 8, you're designing massive systems as a cloud or solutions architect. And by year 12, you're the technology leader. You're the one managing the teams, architecting the systems, and setting the big picture vision. And what kind of jobs are you actually gonna be leading? Just think about the explosion of new roles coming down the pipeline over the next decade or two. We are talking about AI infrastructure roles, like LLM ops, engineers entirely dedicated to running large language models like ChatGPT securely and efficiently. We're looking at specialized cloud architecture roles, like cloud AI architects. We're even seeing next-gen security roles, like digital twin engineers, who basically build virtual replicas of physical systems so they can test for vulnerabilities without ever risking the real thing. This specific adaptive software engineering methodology you are learning right now, it acts as the master key to unlock every single one of these cutting-edge, highly lucrative specializations. I want to leave you with this really powerful summary from our source material. Programming alone is no longer sufficient. Modern engineers must understand automation, deployment, security, and continuous learning. That right there, that is the whole secret. This isn't just about passing a class. This is a transformation. It is about evolving from a student who writes scripts into a future-ready, adaptable tech leader capable of steering the entire technological landscape. So, as you open your laptop and kick off this journey, I'll leave you with one final question. Knowing everything we've just uncovered about exactly where the industry is going, will you just write code or will you build the future? The choice is entirely up to you. Thanks so much for joining me on this explainer, and I will catch you next time.